All right, this video is going to talk about inverse trig functions for pre-calculus. Woot woot! Okay, so before we talk about the inverses of trig functions, we have to remember what the trig functions themselves look like. So I've labeled my graph here for the sine function, and the sine function itself is of course a function because it passes the vertical line test, and every x value has a unique y value, so our x values don't repeat. So let's talk about what it means to be an inverse. Now, we've talked about inverse functions before, so remember that when we have inverses, it means that the x and y values switch. Well, when that happens, your graph switches as well. So what we're going to do is we're going to graph the sine function. We're going to make this pi and this pi over 2, this negative pi over 2, and this negative pi. This would be 1 and 2, and negative 1, negative 2. So basically what has happened, I have switched the x and y axes. So now, rather than the pi values being on the x-axis, they're on the y-axis. So what is this going to look like? Well, as you might have guessed, it is going to look something like this. Okay, so there is my function, just a portion of it, but I want you to notice that this particular graph is no longer a function. So if we're talking about trig inverse functions, that means I have to limit how much of this graph I draw. So, since we can't have x values repeating, we want to restrict our parent graph to just a portion. So we're just going to restrict it to this portion right here. So when I talk about an inverse trig function, I am only talking for the sine function about this bit right here. Okay, and let's think about that on the unit circle. That means it's going to restrict the quadrants for the trig inverse function values. So notice that this is positive 1 here. This ordered pair would be 1 radical, square root of 2, why can't I say that? Pi over 2, sorry kids, and this one is negative 1 negative pi over 2. So that means I'm going to be restricted to specific quadrants in my unit circle. So I will talk to you more about those here in just a moment. Okay, so we're not going to worry about domain and range for now. All right, so let's look at the cosine function. The cosine function also is a function because it passes the vertical line test, but the inverse, of course, is not going to. So I'm going to, again, let this be pi over 2 and pi, negative pi over 2, negative pi. This will be 1 and negative 1. All right, so normally if we were going to graph this, it would look something like this if we were going backwards. Okay, that's not right. Okay, it would look something like that. If we were to continue with this, all right, that would be our cosine graph. But because we want to look at the inverse, we are only concerned with this portion right here. So again, that means the quadrants we'll be referring to in our unit circle are going to be restricted. That's pi and that's 0. So I'm going to talk to you about that as we look at how to do these problems. Okay, and I didn't mention this before, but I want you to recognize that inverse functions look like this. Y equals sine to the negative 1x, or y equals arc sine x. These mean the exact same thing. So again, for cosine, that's what they would look like. We are going to talk about inverse for tangent because we don't have to graph these. We are just using them to find values. So again, if we are restricting the graph because it has to remain a function, I am going to label these for inverses just like that. And where I have asymptotes, I will still have those Okay, so now this is just restricted to one portion of the graph. It's restricted here. Okay, so that is what my tangent inverse will look like. Okay, so in the next video, I'll teach you how we use these and why we use them.